All
Hello,
right.
we're here. We're
Yes,
live.
we're live.
That's great. Cool. Well, hello, everybody. Thank you for being here today and watching this live stream. My name is Skyler Hartle. I am a product manager over at Microsoft Azure. I work across a lot of our different kind of PaaS services, including Azure App Service, Azure Static Web Apps, Azure Container Apps, Azure Functions, and most recently, I've been working on a new experience that we call App Spaces. And I'm going to be here talking about the intersection of App Spaces and Static Web Apps and going through a nice reg app and how that all works with those two services. I also got Dheeraj here with me. Dheeraj, you want to introduce yourself?
Yeah, sure. My name is Dheeraj, and I am a product manager for Static Web Apps, and super excited to hear about App Spaces and how it works with Static Web Apps in this live stream today.
Awesome. Cool. Well, before we kick things off, I don't know if we have any viewers out here in the great Pacific Northwest, but up here in Seattle, we're having record-breaking heat wave right now, and so I'm in the beautiful Microsoft office out here in Redmond, trying to stay cool where I don't have AC. Dheeraj, how are things going for you out there in Chicago? How's the weather?
It's been good. Balmy days. We're having like 70-degree days, and I love being outside, so getting some good sun in.
Good. Well, I'm glad to hear that. That's what I'd like to be doing right now. Our summer kind of officially started in Seattle like 5 days ago, and then we got this massive heat wave that came through. So that's always fun. But hopefully, other people out there are staying cool and are doing all right with all these kind of crazy weather things that are happening over the past week or so. I have a couple friends in Houston that are getting hit by the storm. But cool. All right. Well, why don't we go ahead and kick things off? I will share my screen and we can just start going through this. Feel free to ask questions and we'll try to address them in real time too. So go ahead and go over here and throw this to the stage. Cool. All right. So if people can actually read this, I'm going to go ahead and change this to our nice little cinema layout and we're going to go ahead and get started. Cool. So as I mentioned before, I'm going to be here talking mostly about app spaces today and the intersection of app spaces with static web apps, but I think it would be helpful to first provide some context on what app spaces actually is. App Spaces is an experience that we've been incubating for the past year or so. It went into public preview at Microsoft Build, so just a couple of months ago. The way that we kind of talk about app spaces is as being the fastest way to deploy and manage your intelligent app workloads without being a cloud expert. We developed and designed app spaces to obfuscate and kind of remove a lot of the complexity that is often associated with Azure. Azure is a wonderful, great, super powerful cloud, but often you don't need, let's say, 250 of the services that they offer, but rather kind of a subset of those services, especially in the kind of app development and app hosting space. With the advent of all these new intelligent apps and AI and Gen AI and all that kind of stuff, we realized there's an opportunity to really focus down on kind of what are the core competencies around app hosting and how can we provide an experience that really just lets you focus on building out your apps and not necessarily focusing on all the difficulties or the complexities of hosting infra and managing infra. And also do this kind of in a seamless way to allow people to go and do those kinds of things within Azure when they want to. App Spaces is built as a layer above static web apps and container apps, actually. So under the hood, we deploy to Azure Static Web Apps for certain types of workloads, and for other types of workloads, we deploy to container apps. So for front-end sites that you're familiar with, if you're a Static Web Apps customer, we deploy to the Static Web Apps, right? For things like backend apps, things like APIs, web apps that have some sort of a backend component, like it's an Express app or a Flask app or FastAPI or ASP.NET or something akin to that, we deploy to container apps. App Spaces helps you kind of thread these front end and back end components together along with databases into one cohesive app. we actually consider a front-end piece and a back-end piece to be components, and that the kind of collective grouping of those components we consider to be your app. And so we often focus on kind of full stack app scenarios or 3-tier app scenarios. In a nutshell, AppSpaces makes it easy to deploy your app to the cloud directly from GitHub. If you have a repository already hosted in GitHub, you can very easily connect it and just deploy straight to one of those services. And I'll be going through and doing a more holistic demo showing all of this. We make that super simple to do, as well as kind of automatically configuring your CI/CD. So additional deployments just happen kind of automatically. So you can just get deploying and going really fast. We make it really easy to get started with new intelligent app scenarios beyond and other scenarios as well. Obviously, we have kind of a robust platform, but we've been focusing on building out templates that let you do these, what we call one-click deploys, where you just click a button and all of a sudden you have a kind of a boilerplate template deployed in the cloud for you to go play with. Or we also have the more comprehensive solutions where, again, it's a kind of a one-click button and it will deploy a whole solution for you, including a front end, a back end, and a database that you can use as your starting point for an intelligent app, whatever you might be building. And that's what we're going to kind of focus on today for the demo. The last thing is that in addition to the deployment experience, we have a pretty comprehensive management experience for how you manage all those components of your application. And again, it's streamlined to kind of focus on the core components to really alleviate a lot of that complexity. And so you can just focus on building your app as opposed to managing the infra. Cool. So with that said, I'm going to go ahead and just go kind of into the demo piece here. But I realized, excuse me, there's a little bit of context setting along with this that we probably need to do. Namely, well, what is retrieval-augmented generation, right? If you're here, hopefully you have a little bit of context on this. I provided a really loose definition here that I stole directly from the NVIDIA website. But at its most kind of naive definition, retrieval-augmented generation is a technique for enhancing the accuracy and reliability of generative AI models with facts fetched from external sources. Often, most of the time nowadays, when they say fetch from external sources, these involve vector databases or some sort of a document storage that lets you store documents alongside vectors / embeddings, which I'll talk about in a second. But the idea is that we have all these models and APIs, things out there that we're using, and we're sending a prompt to, and it sends back a response to us, but it doesn't always have all of the context that we want it to have. And so we need a way to enrich these LLM's context, and that's where RAG comes in and is really useful. The app that I'm going to be showing today is super simple. We developed this solution to be just probably one of the most bare bone RAG applications we could think of. So what we have is a front end app that we've built in React that makes calls to a backend app that is a FastAPI app. This FastAPI app does primarily two things. The first thing it does is it goes to OpenAI and fetches these embeddings. An embedding is a vector or a set of coordinates that is returned from the OpenAI embeddings API. This vector is stored in a Qdrant database, which is the other part that the backend API helps broker. These embeddings get stored into the vector database, and we're using Qdrant in this case. The coordinates get stored alongside the document for retrieval, and then are used usually in subsequent calls for whatever question is being posed within the intelligent app. This is often used in like chatbot scenarios where if somebody might ask a question about this is just an example, but ask a question about a weather for a particular region, or that's kind of dynamic data. But if it was stored in there asking about the historical weather for a region, you would go and kind of go through this process of sending that question to OpenAI, retrieving an embedding. That embedding then gets used to search the vector database, and the vector database returns back the document that is most closely associated with the request from the person. And we'll go through what that looks like. We have a whole app, so I'm not going to spend too much time on this slide. As far as the agenda goes, we have a lot to cover. I'm going to do a brief rundown of app spaces before we get to the actual demo, go through the kind of the homepage, talk about bring your own repository. I'm going to go through the deployment experience a little bit, logging experience, how to get back into Azure, and then we're going to go into the actual reg app itself and kind of step through what this looks like from the app spaces context. Cool. So I'm going to go ahead and flip out of here and let's just go ahead and get going. Okay. So, excuse me. I'm going to make this a little bit larger. Hey, Dheeraj, if you could keep an eye on chat and just make sure that people can see this. Sometimes it can be kind of hard on this recording stuff to see what's going on.
We'll let you know.
Cool, appreciate it. Cool, so this is the App Spaces homepage. From the homepage, you can do 3 things. You can deploy code from your GitHub repository, or you can deploy one of our sample spaces, which are those solutions I mentioned before, or you can deploy a starter component, which is just a boilerplate component. So basically like a naked Express app or a Vue app or a React app that just goes and gets deployed, and then you can go and deploy to it and make changes and modify. It's a really fast and quick and easy way to get started. We know that sometimes it can be difficult to get deploying on Azure, so we wanted to provide these components, these starter components, to help people get started as quickly as possible, at least with something from a fresh greenfield perspective. We have a lot more of these coming. The service is still in public preview, so we're going to continue to build out both the sample space library and the starter component library. So yeah, look to the future to see more of these. So going into the bring your own repository scenario, if we click GitHub repository, this takes us to our create screen, which is fundamentally similar to other Azure create screens, but we've streamlined it down to kind of only focus on the essentials, right? So I'm already, excuse me, I'm already authorized to GitHub, but normally if this is your first time, you would connect your GitHub account at this screen, and you would allow permissions to go and look at your repositories and your organizations and so on and so forth. So since I'm already authed, what I can do is I can select my organization, and from there it's going to populate the list of repositories that I have available. I have a lot of repositories in here, but if I wanted to deploy some sort of an app, I would choose from one of these repositories and I'd go through the rest of the process. So I'm going to start to deploy a static web app just to show what this looks like. So go ahead and filter down to that. See if I can find it. The funkiest. Oh, hold on 1 second. Sorry, I have over 200 repositories in here. Funkiest API UI live.
Could it be in a different account?
It could be. Let me just go look for it really quick here. Let's see. It's been a while since I've used this application, so it could just be under. I could just be misremembering. Oh, there it is. It's the funkiest API, all one word. Cool. So the funkiest API -UI live. From there, I select the branch main, and after we select the branch, we actually will go and analyze the GitHub repository and look for various applications that might be inside the repo. This is in case you have a monorepo scenario where you have a GitHub repository that has a lot of different apps in it. You can actually select down to what app it is you want to specifically deploy. In this case, this is not a monorepo, so I just want to select the root location. I can choose some very basic configuration that might be needed if I'm changing the output location on the static web app, for example, but in this case, I don't need to do that. From there, I provide the app space name, my Azure subscription, and then the region, and I would just hit deploy. I'm not going to do it for this case because our deployments take a couple of minutes, and for the sake of time, I'm not going to show that. But if I won't show the whole thing, but if I click deploy, I can show you at minimum kind of what the provisioning process looks like, which is this new screen, which shows you the number of resources that are still to be completed from a deployment perspective, as well as some details about the provisioning process. This is so you can just have more context on what's actually going on during the deployment, which can kind of be opaque at times within the Azure context. But so this is the bring your own repo. Like I mentioned before, we support like front-end sites, back-end sites. We do this through Container Apps. So if you have a Docker file, then it's super easy if you have a containerized app. But if you don't have a containerized app, we also support the scenarios as well. Close this. That was a really fast deployment, so you're getting a little bit of a sneak peek here ahead of the demo. This actually took us into the app spaces context. You can see that this is the canvas, the app spaces canvas. This is our component here, which is pretty cool. There's a code deployment underway. We split up the notion of infra deployments and code deployments into two kind of discrete sections because infra can take a while to deploy, as can code. So we wanted to make those discrete steps so it was very clear what was happening. All right, so if I go and click here, actually, well, we're in this context. We may as well stay within this context. Cool. Let me zoom out a little bit. So when you click on a component, you actually get a pane that flies out to the right that has all of your management experience pieces on here, including your deployment information, logs, metrics, settings, and info. If I were to click into this deployment, which is currently in progress, we would see more information about the deployment happening in real time. That prior screen I was showing are basically a running list of all of the deployments associated with that component or with that repository. Right now, this is still in the process of deploying, but you can see that it's going through the process of running these jobs. We use GitHub Actions behind the scenes and set up CI/CD for you, which I mentioned before. So it makes it very easy to continue to deploy and develop on your application once you've gone through this process. Cool, this actually ran through pretty fast. So it looks like our code deployment succeeded, which is great. We can go and interrogate any of it's a little bit smaller so we can actually see. We can go and look through all the various jobs, see if there's any information that we wanted to look at. For instance, the build and deploy, we have all of our build and deploy messages, all that good stuff, which is great. This is a static web app, and we can enable logging, which will show logs on the front end, which is a very useful feature. Not going to do it right now. We also have logs for our backend applications, which I'll go into in a little bit. We have the metrics on the component, so you can very quickly see the requests coming through, 200s, 500s, things like that, as well as a very basic settings tab and basic info tab in case you want to explode out into the Azure portal. This is where you would go and do that. I'm just going to show that very, very briefly, but then I'm going to go into the other pieces. So if you wanted to get back into the Azure portal context from app spaces, you would just click on the resource group and you have access to all of the resources associated with the component that was just provisioned. So for example, I can click on the static web app and boom, we're right back into the Azure portal as we know it. And when we want to go back into the app space context, we can just click back here on the breadcrumb and get right back into it. Okay, so that's a little bit, that was kind of a whirlwind tour of some of the pieces of app spaces. Let's go ahead and flip over into the actual reg app and just get going on that piece. So back to app spaces, create app space. Cool. So I mentioned down here before we have our sample spaces and we have our starter components, right? So to deploy the reg app example, you go into the sample space and we have this Retrieval-Augmented Generation reg app, right? Which provisions 3 components, so React front end, a Python backend, which is using FastAPI, and a Qdrant Database. I can click there and I can select my organization. This process of deploying this sample space is going to create a new GitHub repository in your GitHub. When you want to go and dev on the actual app, you just go to that repository, clone it down into your local context, and you can party on it all you want, and then commit the changes and those will be reflected back on the code or back on the app that you have deployed in App Spaces. This deployment does actually take a fair amount of time because we're deploying multiple components. So I'm not going to deploy this one. I'm glad the static web app component deployed so quickly. That was great. But this one has quite a few things under the hood deploying. So I have already deployed this app for us to go look at from the app space context. But the same process I showed before would apply for this one, which would be clicking the deploy button and then kind of waiting for all the provisioning to happen. So let's go look at the reg app what this looks like actually deployed. So these are the 3 components that we mentioned before. After you've gone through that deployment process that I just showed, this is what would appear. Let me go ahead and kick this really quick. But this is what you would see. You'd see these 3 components: your reg front end, your reg back end, and a Qdrant database. I'm actually going to do something here really quick too. Just kick that. Some fun behind the scenes stuff here. Hopefully this guy is awake. There we go. The reg front end and the reg back end are actually connected together. So we do a little bit of kind of magic under the hood to make it so that your static web app is only the other way around. Your back end is only authorized to your front end. I'm going to go through the code to show a little bit about what that looks like, but we have this notion of a connection between your front end and your back end. To use this, you have to include a little bit of code. I'm not going to go too deep into this because that's not really what this particular stand-up is about today. We can go into this in greater detail in the future, but we do have a really fast and easy way to create a secure connection between your front end and your back end, so that your front end is the only thing that can call those backend endpoints that are provided. So we make it super simple to do. It's a really great feature. We should definitely go into it in the future for additional things we talk about. We also have the notion of, let me close this. We also have the notion of connecting our backend and our Qdrant database. Again, this sample space I'm showing did all these connections for us, so you just get this out of the box. But if you provision if you're provisioning your own repositories, things like that, then you would just be doing this manually. We make it super easy to basically connect your database to your backend. These get injected as environment variables that you can reference within your backend code, so that you can access your, the requisite database details from that backend without exposing those in any other place you don't want to expose those details. So why don't we go ahead and just open the app in the browser and see what this actually looks like. So this is the front end built on static web apps. It's, again, super simple, just meant to kind of showcase the most basic version of a reg application. For this app, you need to supply an OpenAI API key to use it. Here, you can always change this. This is just React code, so feel free to modify it as you want. That's the point of this. And I'll do a little bit of a demo. So I'm going to go ahead and grab this API key, which I'll be revoking after this demo. Always good in practice. And I can ask a question in this demo, and when there's things stored in the vector database, which there's nothing stored right now, it'll return back some sort of an answer. But if I ask it something, the request should fail at this point because there's nothing stored in the vector database, and so there's nothing for it to make reference to. But a question I could ask it would be something like, what is the temperature of the room that Skyler is in right now? And if everything went correctly, this should not return back anything to us. And good, perfect, that's what we wanted. But we have this question, which is great. And so let's go ahead and store some information in the vector database so that this actually works in practice. So the temperature of the room Skyler is in right now is over 200 degrees. So we hit store text. Let's hit enter technically. Perfect. That's kind of a little bit hard to see. I'll make it a little bit bigger. But we have this message down here that says embeddings generated and stored successfully. That's that process that I showed in that diagram before, where the backend, the front end called the backend then hit the OpenAI API, OpenAI embeddings API, generated those embeddings, and then stored them in the vector database alongside that text that I just put into that box. So now if I go back up here and ask it, what is the temperature of the room that Skyler is in, we should hopefully get a response back. Perfect. So we get a response back that says, based on document 1, the temperature of the room that Skyler is in right now is over 200 degrees. Down here is showing the related documents that were retrieved from the vector database. This is the document that we just stored down below, and it's giving it a relevancy score, right? And it's saying, hey, based on the question that was just asked of me, this has a 0.86, et cetera, score, right? 1 being the highest kind of relevancy or similarity score that it can have. I'm kind of curious, would Skyler be alive in the room he is currently in? I think that, so I'm going to explain a little bit about how this works, but yeah, perfectly. So basically, I'm asking it a question about, whether or not I'd actually live if I was in this room. I would not live if I was in this room because it'd be over 200 degrees. Behind the scenes, the way that this one is working is that it is retrieving those documents from the vector database, as I mentioned before, and it is taking those documents and sending them to the OpenAI GPT-4 API, along with a very basic prompt, which I'm going to flip over to kind of explain this holistically, but a very basic prompt with that information, and OpenAI is returning back a response to us based on the information it has in order to answer this question. So the ask a question functionality here is making its own call to OpenAI to go and basically answer the question that I'm asking of it, with the information from the vector database that we have inserted in there. We could add more information in here, like human, where Skyler lives, humans can actually live in over 300 degree heat. This should be pretty fast now. Let's just ask the question again. I'm curious to see if it will give us back the correct context. Let's see. Perfect. So it says, document 1 states that the temperature of the room Skyler is currently in is over 200 degrees. Document 2 indicates that where Skyler lives, humans can live in temperatures over 300 degrees. Conclusion, since Skyler is in a room with a temperature over 200 degrees and humans where he lives can withstand temperatures over 300 degrees, Skyler would be alive in the room he is currently in. So great job, OpenAI, for taking in the requisite context and returning back a good answer. Yeah, so this is the most kind of basic bare bones kind of reg implementation that we could do. There's a lot that goes into more complex reg implementations, but probably going to save that for maybe a deeper dive in the future. For now, what I'd like to do is go into some of the code and explain a little bit about how this reg app works, just so people have context. All right, so I'm going to go to GitHub. This is the repository that I created associated with the app space. I like code spaces, so I'm going to go ahead and use a code space as opposed to using something like VS Code, but I could also very easily just clone this repository and look at this code. And this is the repository that was created for me during that deployment process that I mentioned before. So let's go ahead and open this up in code spaces. Okay, dark modern. There we go. Much better. Cool. All right, so this is probably pretty small too, so I'm gonna make this much bigger. Great. So for this particular repository, excuse me, we have the client in this repo as well as the server. So this is a monorepo. The client is the React app that we saw before that I was just playing with, and the server is the FastAPI app that I mentioned before. I'm not going to spend too much time on the client, but if you kind of browse through the directory, you can see that it's a fairly standard, React application. Let's make this, put this down here, change this a little bit over here. Fairly standard React application. There's a few special things that I'll go into, but it's just handling state. We have different components for all those pieces you saw on the web app. And it kind of handles all the brokering and the exchanging and the storing of all the various pieces. So there's one special thing here, which I mentioned before. So since we are using kind of a magical feature with that connection ability between the front end and the back end to ensure that the back end API only accepts requests from the connected front end, there is a special route that you have to call when doing this. And the route is just /API. So when you are designing or developing an API and you want to use app spaces to kind of connect your static web app to some sort of a backend, you have to make sure that your backend API is using this /API within the routes. And then from your front end, you just have to make sure that you're calling that /API / whatever other route names you want to have. Little bit confusing because it's kind of magical, it just works, which is nice, but also it's a little bit challenging because you can't really see the machinations under the hood. But it is really nice and it's really convenient, which is why we used it for this application. And I do recommend playing around with it. There is documentation on the Static Web Apps doc site that kind of goes into greater detail about how to use this. So if you are interested in doing kind of auth this way, it's a great method. Let's go ahead and flip back over to the server. So from the server, this is a very basic FastAPI app. We are using, those injected environment variables that I mentioned before, where we saw that we had the Qdrant Database connected to the reg backend. We can then make reference to those to that data in order to properly configure our database, which is great. I'm going to flip ahead to some of the more kind of like pertinent things. So this app, zoom out a little bit. This app has two. This app has two API endpoints associated with it. It has one for generating and storing the embeddings, which is the store box that we saw within the web app. And then it has another route for retrieving and generating the response. And we'll kind of go through this slowly to kind of talk about like how this works in practice. So let's start with generating and storing embeddings inside the vector database. This is just a really kind of simple, like naive implementation. I'm sure if there's anybody out there who's made more complex reg apps, this will already be familiar to you. But this is just a great starting point if you haven't ever explored this before. So the way this works is the first thing we do is going to be creating a client from the OpenAI Python library. And specifically, we're going to be using the client to call the embeddings API and sending along the text input that we provided in that box that we talked about before to the embeddings API. So all of this basically happens right here in this just short set of kind of code, right? We have our client, we're passing in the API key. We have our response that we're waiting for, which is assigned out to the client. The client's being called. It's calling the text embedding API. The input is that text that's being passed forward from this route getting called. And then we are awaiting that response, and that response is then assigned to this embeddings variable here, and then we're going to do something with it. Namely, we're going to store it into the vector database. There's a few other little like gotchas along the way. Like for instance, we need a vector ID that needs to be a unique GUID of some sort. So we are generating a unique GUID along the way. For this app, just so it kind of works out of the box, we have a helper method above that I'm not gonna go into, but it basically looks to make sure that the Qdrant database has a collection in it, and if it doesn't, it creates a collection to actually store the embedding along with the document that was referenced before. So I'm going to skip past that point though. If you want to know more, just go into the kind of the code and you can dig into these pieces. You do have to prepare like a structure, a specific structure to store the embedding. Different vector databases have different expectations. So we're using Qdrant. So we are adhering to the expected format that Qdrant has. Once we coerce the right format, we then insert the data into Qdrant, and then we're good to go. Now that basically that text document along with that embedding is now stored in Qdrant, which is ready to be used for search. So if we go back down here for search, the process actually looks really similar in the beginning. When we send in a question, like you saw before in the ask a question box, what we do, what happens is that question is sent to the OpenAI embeddings API. An embedding is returned, which is a vector, and that vector is then used to in searching the Qdrant vector database for the nearest vector to it, basically. That process of talking to the OpenAI embeddings API is happening here, very fundamentally similar to what I showed before. The actual search is happening down here under this search results variable. We're using the Qdrant client to search the collection that we defined before. We are passing in the query vector, which is an embedding. And then we're asking it to only surface the top 3 most relevant documents to the search. From here, we have our documents that get pulled from the vector database. So we're just assigning it to this variable, and this is going to be used in the prompt that we pass to OpenAI to actually ask the question. So this line here, which is pretty crunchy, is effectively enumerating all the relevant docs in a pertinent way to be passed into this prompt. And so this prompt here is really basic. It's literally just question, and then it will pass forward the input text that was provided to it in the form of a question, and that was the box I showed before under ask a question, and then it appends all of the relevant documents so that it has context. But if you wanted to create a much more sophisticated system, what you would do is you would play with like this, like the prompt, and come up with, you know, multiple prompts for a particular context that you're pulling from the vector database, and so on and so forth. It can get very, very complex. This is why, you know, things like semantic kernel and LangChain and llama index kind of came into existence, because they help you handle a lot of that process and that brokering and between all those pieces. But if you want a more basic version, this also works. Once you have the prompt constructed, we're going to use the GPT-4 chat completion API to send the prompt along with the documents forward, and just send that to OpenAI and then get the response back. That response is then returned to the front end, which you saw before in the ask a question box, and that's it. That kind of completes the life cycle. You know, our impetus behind creating this was that, you know, LangChain and llama index and semantic kernel are great and are super powerful tools, but they are also can be sometimes very over instrumented for your use case. Sometimes you just need something a little more basic, and this is also a nice way just to kind of get your feet wet when learning kind of the RAG paradigm to begin with. Okay, I think, last thing I'm going to show, because this kind of, I think, includes our kind of the RAG piece, but I wanted to show one more piece around app spaces, specifically within the RAG app space itself. But, you know, so now we have this RAG app, we have this RAG backend, we have this RAG front end. If we wanted to extend the space, or we wanted to use the call the backend from another front end, AppSpaces makes it super easy to do this. So for example, if I want to add an additional component to the app space, I can just click add component up here. Let's go ahead and add like an empty component. So we're going to choose template. I want to add another React app. I'm going to click next, select my organization, and just call it, we're going to call it like reg front end, backup or something, right? Click add. This is going to start the process of deploying a new static web app, as well as creating that a new GitHub repository within my organization. The screen refreshes and boom. And now we have another front end within our space that's currently in the process of getting deployed. And we can, once this is deployed, we can either go into our local context or go into code spaces or whatever, and we can start calling this reg front end backend again, so that we can have multiple front ends consuming the same backend and have it visualized very easily and kind of intuitively from the spaces context. Again, we're going to be filling out a lot more templates as we go along, but these are the kind of set of templates that we have right now. Cool. So I just went over a lot. I'm going to come back over here into StreamYard, and I'm going to remove this for a second and just see, are there any, questions at this point as far as the reg app goes? Anybody have any comments and whatnot? Otherwise, I can just flip back into our last couple of slides for the session.
So it looks like there's one question that came in earlier, asking if AppSpaces will support Azure DevOps.
Right now, we support the GitHub, but I think that AD and GitHub Actions as a result, our goal is to support like a broad set of providers, right? Like we would like to support like ADO and other like Git providers. So that is on the roadmap, but it's a ways down the road.
All right. Looks like we don't have any other questions at this time, so we can continue rolling through.
Cool. All right. I only have one or two more slides. So just kicking back over into here. So I think we made it through most of the agenda here, which is great. I guess this won't let me go into full screen right now. That's fine. I just want to talk a little bit about kind of what's coming for intelligent apps and kind of what we're planning to support in the future. In the very near term, let me close this a little bit. In the very near term, we have new solutions and recipes coming. We want to kind of implement a sample space or a solution for like a basic agent implementation using OpenAI. Function calling, if you're not familiar with that, it's a way to use OpenAI, and I think that it's super powerful, but it can be a little bit confusing, and so we want to provide a basic implementation with function calling at OpenAI. Again, these will be all backed most likely with either vector databases or a more traditional database like Postgres, but a 3-tier application. And then we are currently working on more templates for things like boilerplate apps for Llama Index and LangChain and Streamlit and Gradio, and kind of a bunch of other data and AI related apps, so that when you want to build a comprehensive architecture with all your apps, it's just those templates are available to you to continue to kind of build as you need to. So that's what's coming down the road from an intelligent apps perspective. Obviously have a lot of other features, and we'll be continuing to talk about this heading into the future. But yeah, that's it. I think that's all I got. I appreciate letting us take the time to talk about this. We're very excited. We think this provides a ton of functionality on top of both static web apps and container apps, and it'll be a great place for people who are kind of trying to build from a full stack perspective.
And Skyler, if we could go back, there are a couple community resources I want to go over for static web apps.
Yes, definitely. Let me go back here. Bring this thing back.
Yeah, so there's just 2 community resources that I kind of want to highlight for static web apps. Obviously, we have app spaces coming out, and there's a series of blogs that are related with app spaces, which I kind of showed in our last community live stream. Some new ones here. We had someone from the community show us how to improve SWA CLI performance using a Vite server proxy. Definitely a good read if you're building with Vite. The second link here is from Adrian Hall, another product person here at Microsoft, who demonstrates how you can go to production with Azure Static Web Apps. This includes adding a custom domain and authentication to your static web app. So again, just a couple good reads here that came up in the last month.
Awesome. Cool.
Right.
Well, I think that's it for me. So.
Yep. Let's wait a minute, see if any questions roll in. Otherwise, it's great to talk to everybody. And we're gonna be back soon with more information. If anybody has any suggestions for what they want to see at the next community stand-up, please let us know. Go ahead and drop it in the comments, and we can create more content that way for you guys that you guys want to see.
Yeah, and thank you so much, Dheeraj, for inviting me to kind of show the intersection between app spaces and static web apps and what we're thinking about. So this was great, and thanks to the community for continuing to support us in our endeavors to make all these products better. So.
Awesome. All right, then. I think we can sign off for today. Thanks so
Great.
much, Skyler.
Yeah, thank you.